Test 1, 2. Right one. Come on. Hello. Hello, Jiggy. Are you hungry? You want to go eat? Want to say hi to everyone? Are you hungry? Good morning, Ella.
Good morning.
Got any questions over anything before everyone gets here?
Not really. I just wanted to kind of get in before I forgot about the Zoom.
All right, good. Hey, in that, on Google Classroom, I think it's under contextual problems. I have a Google sheet called house prices in there. If you open up that one, we're going to use that one. So can you see it on my screen or not? Can you see it says square foot and price? So there's what I want everyone to use the same one so we can kind of talk about the same questions. So it's in Google Classroom. And it's, I think it's under contextual problems. Let me look here real quick. So under classwork,
Mhm.
and if you go down to, it's right under the vocabulary. It's the sample data for Seward houses and questions. Okay. Good morning, Lily. I think you got your microphone. Whoop, now I can see you.
There we go.
No.
Good morning.
As everyone's starting to come in here, there's a file. If you go to Google Classroom, for everyone, under classwork, there's something that says contextual problems. It's the sample data for Seward houses. And if you click on the Google sheet, it should look like this, and then we'll be ready. If you guys want to, I want you to go ahead and make a scatter plot of that, and then you'll be ahead of the game. I'm going to talk everyone through it in a few minutes when we'll see who all shows up today. Good to see you, Lily. Or good to see that you're here. Did you catch what I said before, Lily?
Yep, I'm hopping on there right now.
Okay, good. You were muted first, so I just unmuted you.
Yeah, sometimes when I think if everyone is unmuted and you're talking or like anyone's talking, it gets all that like splotchy in there.
Yeah, it is,
So
it is hard to hear.
Yeah,
So,
I try to mute myself as much as I
Yeah,
can when I'm not
that's
talking.
good. So if you guys want to mute yourself to not hear that and then just turn it on when you're ready to talk, that's fine with me.
Okay, perfect.
Hello, Nate.
Hello.
Hey, there's a couple on already. I told them on Google Classroom, there's a section right below the vocabulary that says contextual problem, and it's called sample data for Seward houses and questions. Inside there, there's a Google sheet that looks like the one that's on my screen. So if you want to open that up, then you'll be ready. Then we can get going here in a couple seconds. We'll give the other people a chance to show up. I'm going to grab a drink so I can talk. So again, with that, once you get that house prices open, if you can't find it, just turn on your mic and tell me. But I want you to try and draw a scatter plot and add the least squares regression line in the equation. I'll go through that in a couple minutes when we give everyone a chance to show up. My webcam is kind of off and on. It looks like it might be working today. I don't know, there's something with my connection in my laptop that sometimes it's on and sometimes it's off, so I can't always control that. I think we get new laptops next year, so. And my laptop works a little better than the Chromebook for me, so I'm going to use the laptop for this. All right, I'm going to wait just about 2 more minutes and then we'll get started. All right, I'm not sure if the others are going to show up, but they'll just pop up if they do. I made it so it's not pausing you. So I'm going to go through how you make that graph, and it's pretty easy in Google Sheets. If you just highlight all your numbers there, including the labels, you say insert chart. It should automatically choose a scatter plot for you, and it has the labels. So square foot is the explanatory and price is the response. And then if you hit the, get to the chart editor, it should be popped up. If it isn't, you can just click this and hit edit chart. And it's under the customize. I'm going to go down to series, and then I scroll down a little bit, and then I want to add a trend line. So that's the least squares regression line. And then if you scroll down a little further for label, you just say use equation. Okay. So on your paper, you might want to write down that equation. The price of the house equals 94.2 times X plus 24,723. If anybody doesn't see how to do that, just let me know. Okay. All right, so this is kind of like back in algebra. So this is like the Y. Okay, that's your Y value is your price. The 94.2 will be your slope, Y equals mx plus b. So the slope is 94.2, so that's a rate of change. So if you think about that, so that's saying your price per square feet. Okay, so for every square foot that the house changes, the price goes up $94.20. And then the y-intercept is 24,723. So we'd have to extend this graph back further. Okay, so our graph starts at 750 because that was the lowest square foot that I put. But if I extended this line over for when X was 0, it would cross the y-axis at 24,723. Okay, let me see if I can change that on here. You don't have to do that, but I think I can put a minimum value of 0 in here, and then it extends it over for me. Okay, so my data only went my data started at 725 square feet, if I pull that over a little bit, okay? But if I said I want my x-axis to start at 0, then you can see the y-intercept a little bit better. Okay, let me see if we got someone else show up here. Nope, okay. All right, so now there's some questions that I just want to talk through that hopefully will clarify a little bit of this stuff. Okay, so on these questions, I want to figure out how much a 1,500, 2,000, 2,500, and 5,000 square foot homes sell for. So if you don't have these questions open, it was back in that same link on Google Classroom. So the first three I can answer just by looking at the graph. Okay, so if I wanted to know how much a 1,500 square foot house is, I'd go there. I'd look up at my graph. So again, this line is just a prediction from our data how much stuff should cost. Okay, so if you can unmute yourself, Lily, about how much should a 1,500 square foot house cost? If I slide over here approximately. So I go 1,500 up to that line, then I look over here. About how much would it cost?
Oh, about 175,000.
Yep, somewhere right in there, okay? Now, if you want a more exact answer, I can plug 1,500 in for X using your calculator. So I can take 94.2 times 1,500 plus 24,723, and it gives you 166,023. Pretty close to Lily's estimate. Okay. So we could do the same for the 2,000 and the 2,500. But for the 5,000, our graph doesn't go that far. So to get the answer for a 5,000, we'd have to actually plug that in for X. And when you plug 5,000 in, I take 94.2 times 5,000 plus 24,723. You get 495,723. Okay. Now there's two big words they used in this chapter. They used one, it's called extrapolation. So when we look at the 5,000 square foot house, which would be off our scale, we don't have a 5,000 square foot house in our data. So as far as statistics go, we don't know this pattern is going to continue on for bigger houses or smaller houses. So it's not statistically correct to just assume that that's going to happen. So when you plug in a 5,000 and your data only goes to 2,000, that's called extrapolating. extrapolation, extrapolation, they call that. And you got to be careful with extrapolation because you only have data up to 2,000. Okay, that'd be the same as trying to figure out how much a 100 square foot house, that's a pretty small house, but it would cost somewhere here like 27,000 or something like that. Okay, but again, that's extrapolating. Now, if I plugged in numbers between 725 and 2,000, then our statistics back that up because we have data. That's called interpolation. interpolation. So interpolation is statistically sound. Extrapolation outside your data is a little, it's not safe. You don't have data to back that up. Okay. So I'm going to look at another question here. So then it says, what's the slope of the equation represent? So what is the slope, Nathan?
94.2x.
There we go. So what does that mean if I had to interpret that in context? I mentioned it earlier.
For every 1 square foot, the price goes up by $94.2.
Good. So a quick way, if you ever have to interpret the slope, just think of writing the word per down here. So it's price per square foot. And again, we just put this thing over 1, so it's 94.2 over 1. So for every 90, the price is going to go up $94 for every 1 foot that the house gets bigger. So that's your cost per square foot. Okay. So that's what the slope represents in here. You always want to, when they ask on represent or something, you want to put it in context of the graph that you're doing. Okay. So how about the B value? So what's the y-intercept in there, Ella?
The y-intercept is 24,720.
Okay, so now we got to think about that one. How big is your house when it costs 24,723, Ella?
It is it's 0. So
It's
like
0 square foot. So why would anyone pay $24,723 for a 0 square foot house? Anybody got ideas on that?
the land.
Yeah, there you go. So you have to buy land to put the house on. Okay. So that the y-intercept in this case represents how much the average price for land is based on this data that I had. Now, again, I use this data set because when you just do 10 houses, some of you had a negative slope and you might get some really big values. So I picked some values that made a little more sense in context to this problem. Okay. So again, looking at that, so the y-intercept would be the cost of the land. Okay, so you all got the equation of the line, so that's good. So what's that tell me about the cost per houses? And don't try and overinterpret this. So this thing having a positive association, what's that tell you about our price per square foot graph? Nate? It has a positive association, so what's that tell you?
It says that the more square feet a house has, the more it will cost.
Yep, that's all they want, something like that. So now we're starting to interpret what these lines that we did in algebra, how you actually apply some of those things. Okay, so as the house gets bigger, the price goes up, which kind of makes common sense. So again, some of you, when you turned in your graphs, those of you that turned the ones in from the data you collected, we had negative values. So you have to get a sample size that's fairly decent. I didn't want you to have to get 30 or 40 houses. Okay, so that's why we just use 10, and that's why I'm using this data set, because it's a little more meaningful in context to this problem. All right, so let's go down to the next one. How would it vary if we were collected from other parts of the country? So if I look at this thing, let's say we're going to buy some house down in Florida, right on the beach on the ocean. Okay, so what do you think might change? Anybody can jump in here. What might change if I'm buying a house down in some really nice area on a really nice beach right on the ocean? What do you think would change?
The price per square foot would be much higher.
Okay, well, I'm not sure about that. So price per square feet is construction cost. And I'm not sure if construction's going to be a whole lot more down there. It might be, but what do you definitely know is going to cost more?
Land value.
Yeah, the land value. If you're going to buy a lot down on some beach, that lot might cost you $100,000. Okay, so that might be one thing. So again, if I'm buying in some really fancy neighborhood or on a beach, then the y-intercept's probably going to be a lot more. Okay, now if I'm building somewhere in the middle of Montana where construction price is cheaper, then the slope of the line might be less. So then the slope might be different. The cost per square foot might be different. So again, you don't have to write all these answers. I just want you to see how you can kind of interpret one of these questions, okay? So if the cost per square feet or the construction price is less, then the slope is going to be not as steep, so I can build a bigger house for less money, okay? All right, so based on that, how could you use that graph to help if you wanted to purchase a house? So if this was actual data that you got from Seward and you're going out buying a house, how could this help you out, Lily? So you're going to go out buying and you know you have $200,000 you can spend on a house. About how big a house should you look for?
Like a little over 2,000 square feet, maybe like right around there.
Okay, right. So if I go 200,000 over here, it's probably a little bit smaller than 2,000 square foot. Okay, but right in that range. So different question here. Okay, Ella, I want you to take this one. Let's say you're looking at a house. It's 1,500 square foot, but they're asking $300,000. What would you ask them?
You could ask them like why, if there's enough land or why the price is so high. You can ask.
There you
why
go.
the
You
price
ask them, hey, why is everything so expensive? Okay, so it's a 1,500 square foot house, and you're asking 300,000. The average price should be down here about 175. So maybe it's in a really nice neighborhood, or it's brand new, or something else. But there better be something going on why they're charging so much. All right, Josh, you just got in here. Can you hear me?
Yep.
All right. So what they did, we're a little ahead of you here. In Google Classroom, there was underneath the vocabulary, it said contextual problem, and it had
Okay.
house prices for Seward.
Okay.
So we made a graph of that. We made a scatter plot and added the equation in the line. You know
Okay.
how to do that?
Yeah.
Okay, do that quick and then you can jump in on the conversations here.
All right.
Okay. All right. So there's also some questions that you might want to open up. We're going through those questions right now. Okay. All right. So it can kind of help you. Let's go back and ask one other question here. Let's say you're looking at a 2,000 square foot house and they're only asking $100,000 for it. What might you ask them, Nate?
Well, I just buy it right away. As fast as I
Okay,
can.
now, or you might want to ask them first,
Or-
what?
If there's something wrong with the house.
Yeah, is there something wrong with the house? Why is it so cheap? Okay, because it should be up there over 200,000. If they're only asking 100,000, either you're getting a great deal, or it has termites, or it's going to fall down, or something like that, or it's in a real bad neighborhood. Okay, but this graph kind of helps you what it should cost in there. Okay. All right, so number 8, it said the cost of the lots is about the same in 2 cities. What should be true about the graphs if the cost of the lot's the same? Anybody, what should be true about the graphs? Which part of this was the cost of the lots? Someone jump in there.
The
The
y-intercept.
slope.
Yep, very good. I've heard a couple of them. So the y-intercept should be the same. The next question asks, the construction price is about the same in 2 different cities. What's going to be true about that one, Ella?
Then the slopes.
Then the slope's going to be the same. So if the lot's expensive, but the slope's the same, it's going to be going up at the same slant. Okay, that's the construction price. Okay. All right, so you can spend 200,000 to 250 on a house. Okay, based on this, about what size house could you afford from 200 to 250? So again, you got 200,000 to 250. What's the smallest size house you should probably look at for 200,000? Lily?
About like 1,800 square feet.
Very good. Okay. So 250, we can't quite see that. Is there any way I could figure out what the biggest size for a $250,000 house, how I could figure that out? Nate? Where would I plug 250,000 into?
Just into the y.
Yeah, I'd plug it in for the price here and then solve for X. Okay, and when you plug that in, you got 250,000 equals 94.2 times X plus 24,000. So I take 250,000 minus 24,000 divided by 94.2, and you get about 2,391. Okay, so again, it's just stuff that you did back in Algebra 1, but we're putting a little bit of meaning to it. Okay. All right, the last one. What other factors can affect the price of a house? Josh, your parents ever talk about buying a house?
Yeah, the market can affect the house.
Okay, so yeah, are there a big demand? Okay, so like
Supply and demand.
in Seward, maybe that new box company or that new pet food company's coming in, so houses are selling pretty high right now and going pretty quick. So you ever heard a saying, there's 3 things that you need to consider when you're buying realty? Anybody ever heard that saying? What are the 3 things? No one's ever heard that one? Okay, so when I was growing up, my dad always said this too, and we knew some realtors. They said location, location, location. Why would you say location 3 times?
Because nobody's going to buy a house where it's in a bad spot.
There we go. So location's very important. So I can buy kind of a fixer-upper house in a nice neighborhood and probably get my money back out of it. Okay, if I buy a really nice house in a real crime-ridden neighborhood or a bunch of other houses around it are bad, it doesn't matter how nice it is, it's probably going to be hard to get your money back out of it. So again, there's a lot of different factors. It could be, like you said, what the market's at now, whether it's a new house, if it's all brick, okay? A lot of other things can affect the price of a house, but location's really important, okay? So hopefully that showed a little bit about how you can apply some of those things that we did. So again, yesterday you were supposed to use your own data and then draw in the least squares regression line and put the equation on there. And there was a spot that you could turn that into Google Classroom. Okay. Now today, yesterday you were supposed to watch that video on doing scatter plots and doing calculations from your least squares regression line. Okay. And then there's another assignment that you can work on today and try and turn it in on Monday. If we have questions on Monday, you can do that. So let me switch here quick if I can find it. So I'll show you what I'm talking about. Okay. All right. So I want to get into Classroom. I don't know why it's not popping up for me here. Let me try and refresh that. Maybe it's hidden behind, there it is. Okay. All right, I'm going to click here. If you go to Classroom, okay, and this is in Google Classroom also. Okay, let me pull that back up here. So if I get into the data analysis and I go to classwork, okay, so all those questions that we went through today, you don't have to turn those in. You did have to turn in your graph. Okay, so your housing and Seward graphs, that was your graph that had the least squares regression line in the equation. That's all you had to turn in there. Okay, and if you didn't have the equation or something, you can add that and resubmit it, and then I'll give you full credit. Okay, so you were supposed to look through, there's some questions when you watch the video. You were supposed to answer those. It looks like only one person's turned that in. And then there's this fitting lines to data activity. Okay, so I want you to look at that activity, okay, and I can't see the student view, but there's some questions and some data in there. And I also have the data already typed into a Google Sheet for you, so you don't have to type it all in. So make your graph, add the equation to that, and then try and go through and answer those questions in that fitting lines to data activity. Okay, so that's the assignment today. Okay, so hopefully that showed how you can use some of those least squares regression lines to apply it. And it's really just doing stuff that we learned back in Algebra 1, but now we're putting some meaning to it. So this is the why we do that stuff. Okay. So if you didn't turn in your house graphs from the 10 houses you did, okay, make sure you do that. And then you're looking at this fitting lines to data activity. Okay. Any general questions that I can help out with? Okay, if not, as they come up, just shoot me questions. I try and respond fairly quickly to those. Or if you want to do an individual Zoom question as they come up, feel free to keep sending me email questions whenever you have them. Hopefully that put a little more meaning to why we're doing those least squares regression lines. I want to do one other thing real quick, okay? So I'm going to look at this house right here. So looking at that house right there, Ella, describe that house for me. How big is it?
Is approximately, sorry, I'm looking at the sheet, 1,500 square feet, and it costs a little under $300,000.
Good. So if you look over at your data, it's this house right here. It's 1,460 square feet and $279,000. So one of the questions coming up is going to be, you're going to calculate that residual. How much a difference between the actual value and the predicted value. Okay. So a way to do that, this Google Sheet makes it a lot easier if I can get that over here. Okay, I'm going to leave that equation over here. So this is my actual price of the house. It's $279. Okay. If I wanted to figure out how far this is off, I need to take the actual price minus the predicted price. And you can get the predicted price by plugging 1460 into the equation. So I'm actually going to do it for all these points. So I'm going to click on that first one, and I'm going to say equals 94.2 times my original square footage, that's my X, okay, plus the 24,723. Okay, so that 9,318 would be for this house. That's the actual, or excuse me, the predicted price from my line. My actual price was less than that, right? So to get the residual, I can just take my actual price minus the predicted price from the line, and I get a negative value. Okay, so what's nice is I can go here and just fill this one down. So these are all the predicted prices all along this line. And these are all, got to pull that over just a little bit further. Okay, these are all the residuals. So if you notice, that first one is below the line and it has a negative value for the residual. So if it's below the line, it should be negative. The second one over here has a positive residual, okay, because it's above the line. The next one, okay, it's going up and down across there. Okay, so if it has a residual that's pretty small, that means it's pretty close to the line. If it's above the line, it's a positive residual. If it's below the line, it's a negative residual. Okay, so that's a quick way to figure out the residuals. It's the distance between the actual value and the predicted value. Okay, so I just wanted to show you that. I about forgot to do that. So hopefully that will help you on today's assignment. And if something comes up that you're not sure of, shoot me an email and we'll try and go through it. Okay. So if no one has any other questions right now, thanks for showing up. Hopefully that'll make your problems easier and we're understanding it. Any general ones before I go? All right, if not, then I'm going to go ahead and close this off and you guys all have a great weekend.